Hi, let's continue with our session. This is within Unit Standard 9009. So let's go and go through the graphs. So graphs are just a visual representation of what is written in a data table. So there are many types of data of graphs that we can use, and it usually depends on what you need to represent and to whom the representation is made. For example, we've got a bar graph in a histogram, a pie chart, and a broken line graph, and there's also some other types of graph, your pictographs, and so forth. So in this instance, we'll just look into these four main types of graphs. As mentioned in your learner guide, there's many types of graphs that are in place. So going to page 15, a pictogram, graphs that show data by using identical pictures instead of figures and lines. So in this type of pictograms, you find that instead of using figures or lines, it's instead of pictures. So for this instance, there's an example that you're given about Susie, who has encountered many telephone calls. The people in her department make calls during the day. So this is the data that is being collected, and Susie decided to draw up a pictogram to show the data she has collected. So instead of using lines and figures, uh, Susie draws up a pictogram to show the number of calls made by each person. So Susie managed to use a diagram, or a diagram in which symbolizes calls that are made by each user. So this is just an example of a pictogram. The key for the graph is even shows you we've got 10 calls. We've got 10 calls, and you can even check these are the users that these are the users managing. I think the one, this symbolizes one call, symbolizes 10 telephone calls. Yes, yes, correct. One, this diagram represent one diagram represent 10 calls. So if you can check, we've got about 1 2 3 4 5 6. We've got about 60 calls. Let's just check and verify. Janie, yes, 60, rounded off to 60 calls. That's correct. So one represent 10 calls, 10 telephone calls. So this is just a representation of a diagram being done. Susie managed to do this in accordance to a pictogram. So you can use any other form of representation based on what the statement is all about. So moving to the bar graph and histograms, a bar graph and a histogram can be used when the data needs to be grouped into periods and the frequency of each period needs to be clarified. So the main difference between these two graphs, the bar graph and the histogram, is that when we draw a histogram, we do not leave spaces between the columns as with the bar graph. So if you can check, let's just go up to page 14. The difference between these two graphs is that with bar graph, there are spaces in between your bars. Compared to histogram, there are no spaces in between. So that's the main difference between a bar graph and a histogram. So in most common cases, you'll be asked to provide an histogram based on the frequency table that you've given, or a bar graph. So you just have to know the difference, what it is in terms of a bar graph. It doesn't have spaces in between. So for moving right along, okay, these are just uh, features or pointers regarding the bar graphs and histograms, you can just go through this. It will give you further information about histogram and bar graph. So I just highlighted the most important points. Like for instance, the histogram are used if the data classes are continuous. So there's an example given, part of a bar graph. So let's just go through that example. A farmer wants to compare the amount of fuel used by a number of vehicles on his farm. He has summarized the data in a table. So we've got a table, a data table. I've got the descriptions and our figures. So within our descriptions, we've got vehicle, tractor, truck, bakkie, and car. The liters of fuel used in June 2006, and the figures for tractor is 7 30 100 545 and 150. So he must construct a bar graph because a truck is very different to a car. So this is a representation of a bar graph, and that's it. There are spaces in between. So on the left hand side, which is our y-axis, we've got the liters of fuel, and the x-axis we've got the vehicles that we have. So we've got a tractor, a truck, a bakkie, and a car. So this is just a representation of a bar graph, and always a bar graph has to have a heading. So the liters of fuel used by vehicles in 2016. So it has been retrieved from the statement that we were given. So a histogram are used if the data classes are continuous. For example, a farmer wants to see how many tons of carrots a certain field produces per year from 2000 to 2006. There are no spaces between the bars because 2000 borders on 2001. So time is continuous. You could also use a line graph. So on this example, I've got the data table that was drawn up. So in this instance, because of the 2000 and 2001 is continuous, there is a space. Remember, when histograms are used when data classes are continuous. So in this instance, um, uh, 2000 borders on 2001, so it is continuous. From 2000 to 2001 is continuous. So data it's continuous from that cycle. So hence why it shares, there is a space between 2000 and 2001. So these are just your types of graphs that are given, and this is most likely questions that you will be asked. We have done this, and you'll need to draw an histogram based on the frequency table that you were given. So the good thing that we have managed to do a frequency table, and your class intervals that we have done, we completed, we good. And now we can based on the information that we got, we can easily construct our bar graph or histogram. So in this instance, this is a histogram because of there are no spaces. But if the years or the ages were continuous, we would have spaces in between. So a pie chart, graphs are that represent the data as segments of a circle. The various data will take up to certain angle of a total angles in a circle of 360. So you just have to know that a pie chart, its circumference is 360, and also when we calculate or want angles within our pie chart, we need to total our figures to 360. So let's look into this example that was provided. So in a community, a researcher named Janet is collecting information about many people having access to telephone. So she goes about asking questions to the community and arrives home with the following data. So we've got descriptions and figures within our rows and columns. So details, we've got home telephone, cell phone, public phones, and no access, your tele. It's a representation that we have based on the number of telephones made from home. So we've got 33, and cell phone we've got 42, public phone we've got 50, and no access we've got 23. In total we've got 148. So now Janet needs to calculate the percentage and the segment based of the on based on the segment of 360 that you use to draw up the pie chart. So this is quite much more simple. So in percentage wise, what we need to do in order for us to get the percentage right, but we won't use these percentages on our bar graph. What we need to do, the percentage right gives us much more view and or an understanding of what is the percentage based on the telephone. So we might take up the 33 within our frequency divided by the total and times it by 100. That will give you a percentage based on the home telephone. We use that same approach to cell phone, public phone, and no access. Now we want to use these figures to get to our degrees within our pie chart, and once we draw that, it's much more easier. So now the first thing that we need to do within our home telephone, what we need to do, we need to take out the 33, we need to divide it by total, and then times 360. As you can see, that will give you the degrees within our pie chart. We use that same approach within these other descriptions: your cell phone, your public phone, and no access. It will give you degrees. When you total these degrees, it has to give you 360. So if you can take up, like for instance, if you can take 80, you plus it by 102, you plus it by 122, and you add by 56, it will give you 360. So that's how you get your degrees within a pie chart. So now it's much more easier for us to draw a pie chart. Let's say for instance, we want to use those figures and draw a pie chart. We'll go to your features within your Microsoft. Let's just go through that. Let's just check. Okay, shapes. I want to use a pie chart. Go to charts. Okay, perfect. And then you go to pie chart and you click OK. And the data that we have based on, okay, is it session 2 or session 1? Nah, it's session 2. We need to go, let's go back. Okay, sorry about that. Okay. Let's check. Okay, this is probability. Okay, yes. So based on what we were given, we will name our data home telephone, uh, home telephone, home telephone, home telephone, cell phone, cell phone, public phone, public phone, and no access. So we've got an 80, we've got 102, 102, we have 122, 122, and also we've got access, which is 56. And voila, where's our and now we can draw up, where's our pie chart? Our pie chart has to be somewhere here. I think there's a system error within, it has to come up somewhere there. I think there was a error within, okay, I think there's an error, so let's just okay, I think there was an error with regards to that, but our pie chart should be the same with the one on your learner guide is being drawn. Let's just do it, let's just try pie chart. Okay, pie chart, okay, yes, perfect. Now we're good. So what do we have? Okay, but the thing is, oh, it's in session 2. Okay, we've got our 80. Let's quickly take in the information that we have. Where is it? Okay. The 80, we've got 102. We've got 122, and we've got 56. Let's just rename these to home telephone, and cell phone, and public phone, and lastly we have no access. So let's do this, much better. I think our pie chart has to be similar with this one. Let's check. Let's check. Where's our pie chart? No, man. Our pie chart has to be somewhere. Okay. Our pie chart vanished. Okay, nah, never. So the good thing is it's similar to the one that we did, and with the features that are used within your Microsoft, it will tell you. So let's say maybe we want to include our data. I want to see the percentages. Let's check. Change the series type. No, man, we just want to edit data. Let's check. No, we're good with that. Okay, text. Edit data. I think we're good. Edit data, you're good, we're fine. I'll look into change the type. No. Okay, I'll just look into how Okay, the good thing is when you hover around, it gives you percentages in terms of your values. Okay, so this is similar to the one that we have the within your within the example that we were given. So if you can check, it's similar to the one that we were given. So this is just how you should draw your pie chart. It's much more easier and to calculate. So you also have the type of graph which is a broken line graph. Broken line, it's drawing the bar graph and histogram. It is used the whole column to show the data. With broken line graph, we use a point, not full columns. So with broken lines, you just jot based on the data that is given, and it's not that complicated as is how is being displayed on the learner guide. So this is a representation of a line graph. So normally you would be given points to jot down. So with that instance, you can just combine the points in order for you to do a line graph. So this is a broken line graph. So as it symbolizes a broken line graph, so you will jot down the points that does a line, and in that instance it will symbolize it. By the time you are done, it will represent a broken line graph. So this is just a representation of types of graphs that you have normally within within your stats, but there is quite a lot, in terms. We've covered probability, and now we are done with this unit standard. So session 2, it's more of the language of graphs. You can go through this on your own. This will tell you the trends and how you can extract information from graphs and provide information. So it's not complicated that much. Just go through uh, this example and the trends. It's much more easier because of most of the things we are covered, and it's simple. You just go through what they tell you what to do. It's just the trends in terms of how to extract information from the data table or the graphs that you are given. So by just going through this, you'll be able to understand. So for you, it needs you to focus. Just go through these examples, and you'll understand what it's all about. It's nothing complicated. There's no formulas that are needed to do. You just need you to go through this example and how can you extract information based on the graphs that are done. So we have so now we are done with the unit standard 9009. So we need to move on to the next unit standard, which is 7480. So 7480. So on to the next unit standard. We have the title for this unit standard, which is 7480. Demonstrate understanding of rational and irrational numbers and the number system. So these are just the systems or the functionalities of natural numbers, whole numbers, and so forth. So look into number 1a, which are natural numbers. So natural numbers are all numbers that start at 1 and include all subsequent whole numbers and ends in infinity. So any number that starts from 1 and to infinity is a natural number. So as you can check the range, these are from 1 up until infinity. So those are just natural numbers. So it excludes zero, fractions, or negative numbers. So these are just the functionalities that you need to know that are based within the natural numbers. So B, we've got whole numbers. um, Whole numbers are numbers from 0 up until to infinity, and it excludes fractions and negative numbers. So this is just a functionality for whole numbers. It starts at 0 up until infinity. So that's the difference between a natural number and a whole number. Whole number, it starts at 0 and it doesn't end. It's in infinity. Infinity means it doesn't end, it continuously goes. And also natural number, it starts at 1. So that's the main difference between the two. So moving on to the next slide, uh, which is slide 15, we've got integers. Integers are numbers into two main areas, which is negative integers and positive integers. So integers can be okay. So what we know is that integers are our numbers that are negative. This includes our whole numbers and natural numbers. So our numbers start from negative, ends at negative infinity, and ends in at positive infinity. This includes 0 as well. So 0 plays an important role in dividing the negative and the positive integers, and is neither 0 nor positive. So 0 is natural uh, in integers. It excludes fractions, and our numbers just goes in infinity. So on our number system, on a number line, you can just imagine having a graph that starts at 0 and it goes on to negative infinity, from 0 to left and 0 to right, which is goes to positive infinity. And also we've got rational numbers. Rational numbers includes 0, negative integers, and fractions. So we know fractions. What are fractions? From an example that is provided here, these are fractions that are provided. So this is just a symbolization of what a rational number is, and it ends in infinity as well. So it includes any number divided by 0 or non-repeating decimals. Moving on to the next slide. Irrational numbers. So these are non-repeating decimal. It excludes any number divided by 0. The range is all irrational numbers are that your denominator, your numerator is bigger than the numerator. The numerator is bigger. I think I've highlighted that in slide 19. It's more of an improper fraction where the numerator is bigger than the denominator. Yeah. So in irrational number, your numerator is bigger than the denominator. So that is more of your irrational number. So your real numbers includes all. When rational numbers are combined with irrational numbers, a big set of numbers occurs, which is what we call real numbers. This means that all numbers that exist in our universe come from the big set of real numbers. So these are just real numbers. It includes all numbers from your fractions. These are just real, as it symbolizes real numbers. So these are just functionalities that you need to know in terms of your real numbers, irrational numbers, rational numbers, integers, whole numbers, and natural numbers. I think I've mentioned that twice, but yeah, those are functionalities that you need to familiarize with yourselves with, because on, I think, the 2 unit standards from now, we'll talk more of your number systems, where you'll have to draw your number systems within a Cartesian plane. So you have to understand the differences within the functionalities of these number systems. So let's move on to slide 18. This is just an explanation of the decimal expansion, which is repeating, which is your rational, and expansion, which is irrational, something that we went through. So moving on to improper function fractions and mixed fractions. So a mixed number is made up of a whole number and a fraction. That is more of a mixed number. So this is more of a mixed number. An improper fraction is one that the numerator is bigger than the denominator. For instance, as you can see the example, 7 is bigger than 4, so we call it as a improper fraction. We'll get into the examples below. We'll just do on slide 20 the examples from doing improper to mixed fractions. So I'll just on just I just need a blank. Let's check. I just need a blank. Let's check. So that I can much better. So now we can work. Okay, perfect. So now what we need to do, we need to do examples. These are examples. We have to change the properties from improper to mixed. So we'll work out this on the side. Okay, so now let's get into our example. So we've got 9 over 4. We've got 9 over 4. So you wanna, this is an improper fraction because of our numerator is bigger than the denominator. So we wanna write it in to a mixed fraction. So how do we do that? We need to use long division in order for us to represent that. So in this instance, we're going to use long division. We have 9. So how many times does 4 get into 9? 4, how many times that 4 get into 9? We know that 4 get into 9 2 times, and 4 times 2 is 8. There's a minus. 9 minus 8, it will give you 1. So in this instance, to represent that, we'll take the 2, which will be our whole number. So it will be 2, 1, it will be 1 over the denominator stays the same. So we managed to write that in a mixed fraction. Just to repeat that, 4, we take 4, 4, how many times does 4 get into 9? It get into 2 times, and 2 times 4, it gives you 8. 9 minus 8, it will give you 1. So we can represent that in terms of let me just write it. Okay, so that I leave space so that you can answer. So 2 will be our whole number. We've got 1 over 4. So let's do another example also. We have 7 over 4. We've got 7 over 4. So we're going to use long division. We've got 4, 7 inside. So how many times does 4 get into 7? It gets 1 time. 1 times, so 1 times 4 is 4, minus 7 minus 7 minus 4, the answer is 3. We can therefore say 1 will be our whole number, 3 over 4, denominator always stay the same, always stays the same. So let's verify that this is true. You get 9 over 4 or 7 over 4. So how can you do that? We're moving from mixed to improper. What we can do, you times this number by this and you add to this. So 2 times 4 is 8 plus 1, it's 9 over 4, which means this is true, is correct. We managed to get that correct. And also let's verify that this is true. 1 times 4 is 4, 4 plus 3, it's 7 over 4. So that is also correct. So this is in the correct form. So you managed to convert from improper to mix, and vice versa from mix to improper. So there are 2 examples that I would like you to do on your own just to check whether you do understand. You'll use the same format. What you need to do, from the next example, we have 21 over 2, 21 over 2, and also we have 35 over 12, 35 over 12. So what we will do, please do this on your own. Please do this on your own. These two. So the first thing that you need to do regarding this, you'll have to use the long division. You'll put 2 inside 21. You need to check how many times does 2 get into 21, give you an answer. That answer, you times it by 2, and then the next step you'll minus that answer by this, then you get the total. Then this will be your whole number, and this will come your numerator. So this will be your numerator, this will be your whole number, which is this, and your denominator will always stay the same. It won't change, it will always stay 2. So same approach. You use the same approach with this example. So please do these 2 examples, and just contact your facilitator once you are done with it, or even if you don't contact your facilitator, but make sure that you do this and attempt on your own so that you understand, because on your formative and summative assessment you will be asked to convert from improper to mixed, or vice versa from mixed to improper. So that's it with converting from improper to mixed or vice versa. Okay, so now what we need to do is to convert from fraction to decimal. So we've got the three equations, not even equations. Let me just give you another one, which is 17 over 4. Yeah, perfect. So So we'll do these equations just to explain how to solve in terms of converting from fraction to decimal. So the numbers that we have, we've got 2 over 5, 2 over 5. So what we need to do, we need to use long division in order for us to convert from fraction to decimal. So what we need to do in this instance, we need to use long division, and in our long division method we'll include a 2. So in our long division we will the first step that we need to do is to, how many times does 5 get into 2? 5 times getting into 2, it's 0 times, and we include a 0 because of we deal with decimals. So how many times does 5 getting into 20? That is 4 times. So how many times does 5 getting into 20? That is 4 times. So we can include that. We need to include a comma there, and into 4 times, and then 5, and then 4 times 5, it gives us 20. So we'll have to minus this, and the answer, when you minus 20 plus 20 will give you 0. So our goal or our aim in this instance, what we need to do is to get a 0 at the end. In this instance, our final answer will be on the top. So 2 divided by 5 will equate to 0.4. How did we arrive there? We took out 5 firstly. The first step was to get 2. How many times does 5 get into 2? It gets into 0, and then we include a 0 onto the next step. We need to include a 0 onto on the right side within our long division, and we need to also use the first step in terms of saying how many times does 5 get into 20. It's 4 times, and then 4 times 5 will give you 20. So when you minus 20 by 20 will give you 0. So the final answer is the one that you have on top. So we've got 0.4, which is the answer that we have. So moving on to our next example, we've got 1 over 4. We'll include a 4 on our long division. We've got a 1. The first step, what we need to do, how many times does 4 get into 1? 0 times. We need to include a 0. So this is 10. We assume this is 10. So how many times does 4 get into 10? It gets into 2 times. It's 2 times, and 2 times 4 is 8. So we'll include 0 0.8. 0.8, there's a minus. 10 minus 8, you get a 2, so that is 0.2. So we need to add a 0 again. In that 0, drop down the 0. So we've got 0.20. So how many times does 4 get into to 20? It's 5 times. Then 5 times 4, it will give you 20. And with that, we minus, and the answer is 0. So the final answer is 0.25. So how did we arrive here, or how did you arrive to the answer that is 0.25? We took out 4 out of our denominator. Our denominator will always be outside, our numerator will be always inside. So how many times does 4 get into 1? It's 0, and we have to include a 0. So we'll assume that this is 10. So how many times does 4 get into 10? It gets into 2 times. We'll write it on top. and 2 times 4, it will give you 8. So you use the functionality by saying this is 0.8, but we assume this is 8 and 10. So 10 minus 8, it will give you 2. So since there is a 0, we need to bring that 0 down, and the 2 will convert into 20. So how many times does 4 get into 20? It gets into 5 times, and then 5 times 4, it's 20. When you minus that, you get a 0. So that is the final answer. So let me do the last example, which is 3 over 8. So 3 over 8, 8 will be outside. On our long division, we've got our 3. Okay, so how many times does 8 get into? 3 times 0. We need to include a 0 also. Again, how many times does 8 get into 30? Get into 8. What you can do, you can use your calculator in order for that to solve that. So 8 times 5, it gives you 40. 8 times 4, it gives you 30. 8 times 3, it gives you 24. Because which means that 8 get into 30 3 times, so you'll have to include the 3 on top. 8 times 3, it will give you 24. It's 2.4. When you minus 2.4, 30 minus 24, it has to give you 6. So that is 0 0.6. We need to include a 0 as well and bring down that 0, which is 60. And how many times does 8 get into 60? You'll have to use your calculator. 8 times 6 is 48. 8 times 7 is 56. So it's 7 times. So we'll include 7 times. 7 at the top. And 7 times 8 is 56. So it's going to be 0 0.56. This is 50. This is 50. Let's increase. Okay, this is 50. When you minus 60 minus 56, it will give you 4. So it's going to be 0 0.4. We include another 0. We bring it down. So it's 4. So how many times does 8 get into 40? I think it's 5 times. Yeah, 5 times. You write the 5 at the top. 5 times 8, that is 40. And when you minus these two, it will give you a 0. So the final answer is 0.375. So that is it in terms of converting from fraction to decimal. So I would like you guys to attempt this 17 over 4, convert it from fraction to decimal. So that's it with this exercise. So let's continue. So I just would like to talk about like terms and bases and exponents. So we've got a base. A base is it could be a coefficient or a variable, and an exponent could be a number or a variable that is within a base. So this can be a coefficient, meaning it could be a number or a variable, which is a letter within a variable. And in this instance also, it could be a number or a variable. So this is what you find within a base. So in instance, you may find that there's an x, x squared plus x squared equals to 1. So this simply means that our bases are the same, and anything that is within the left hand side is equals to 1. So x could be any number. In this instance, our bases are the same, and we can add these are like terms. So like terms is a term used that whenever our bases are the same, we can add the like terms, even if maybe you can find an x2 plus x3. We can add these because of our bases are the same. So these we refer them as like terms. We refer these as like terms. And we've got unlike terms. Unlike terms is an equation something like this, times x squared. So these are just unlike terms. Unlike terms because of our bases are not the same. This is an x, this is an y, so our bases are not the same, we cannot add. So like terms is when our bases are the same, even if our exponents are not the same. But when our bases are the same, we can add the bases. These we refer them as like terms. When our bases are not the same, these we refer them as unlike terms. So this is just a basic in terms of how we should go about. So let's say maybe for instance, we have a times, we've got x squared times x squared. So our bases are the same. We can take as 1 when there is a times. We don't add our base our bases. When there's a times, we can add our exponent. Where in this instance our bases are the same, what we can do, we take the base as 1 and add our exponent. So it's going to be 2 plus 2, it will equate to x 4. So this is how you should do in terms of how you go about. So if we have a divide in between when our bases are the same, what we will do, we've got x squared, we'll use minus into our equation or our answer. We'll take the base as 1, we'll take 2, we'll minus it by 2, and our base will be 0. So anything to the power 0 will give you 1. So this is how you go about in terms of adding your like terms and your unlike terms. You can use this on your learner, on your summative and formative assessment. You will be asked to use this type of approach in terms of answering or simplifying the equation that you were given. So another thing that I want to highlight is what we call the BODMAS. I think familiar with BODMAS. We use that when we're given complex functions. So board board uh, so this simply means brackets over division, multiplication, addition, and subtraction. So you often use when we have complex functions within what we were given, and we can solve that. So we'll just go through that on one of the example based on the on your learner guide that we were provided. So we are done with unlike terms and like terms and BODMAS. So we can just go through your learner guide. So on your learner guide, I've got your formative assessment. So I would encourage you to attempt your formative assessment. So far we've covered 2 unit standards. We've covered 9009. So on 9001 session 1, for question activity 1, the Weather Bureau collected data from 25 weather stations in the Free State area connect concerning the number of hours of bright sunshine during January and June 2005. So you are given these data set, and you need to draw up a frequency table, a tally format for both January and June. Use the class intervals from 100 to 09 and etc. So the good thing that you are given a class interval that you need to use. So you'll use this class interval based on what you're given. So you'll create a table for these both, for both June and January and June. So we have done that. I've provided examples and how to attempt this question for A. And B, what is the modal class for January? And C, what is the modal class for June? And D, what can you conclude if you compare the two modal classes calculated above? And E, you need to calculate the mean for both January and June. F, you need to calculate the range for both January and June. And G, what conclusion can you reach if you compare the ranges calculated in F in your conclusion the same as the conclusion that you reach in D? So this is what you should do for activity 1. The mark allocation is for 10 marks. Please adhere to mark allocations. The good thing that this activity is based on 10 marks. So activity 2, what you need to do, you're given a data set. A farmer kept count of the number of liters of milk his cows produce per day. So determine a suitable class interval. So you need to come up with the class interval based on this data set that you were given. So you need to construct a stem and leaf diagram to show the data. And B, this is the same question. C, you need to determine the molar class of your distribution. And D, on how many days were less than 40 liters of milk produced. And E, you need to rewrite the numbers in ascending from smallest to biggest and determine the median value, which is the middle number. So F, you need to give a reasonable explanation why the amount of milk produced varied so much from day to day. So that's it from activity 2 concerning unit standard 09009. Okay, so moving on to session 2, you're given a pictograph. It's activity 3. The pictograph below shows the number of hours of sunshine per month in 1998 from January to June in Cape Town. This is a pictograph of the number of hours of sunshine per month. So one sunshine represent 1 hour. So which month had the most hours of sunshine? You'll have to provide that. B, which month had the least hours of sunshine? C, which month had 9 hours of sunshine? And D, how many hours of sunshine did May have? E, how many hours of sunshine did June have? And F, how many hours of sunshine was there altogether in the whole period of January to June? Remember that one sunshine equals to 1 hour. So this is quite tricky. Which month had the most hours of sunshine? So you'll have to specify which month. And which month had the least hours of sunshine? You need to specify which month, not the hours. And then which month had 9 hours. So in order for you need to calculate how many sunshine you have within your pictograph. So the questions are a bit tricky. You just have to focus and figure out what do they actually ask for, you know. So like for instance, how many hours of sunshine did May have, and how many hours how many hours of sunshine did June have? So they are actually asking about the month, the hours compared to the previous questions in C, B, and A, where they actually ask months. So these are the two things that you need to adhere with the differences. So in activity 4, the following stem and leaf diagram shows the total number of points scored in a series of a basketball games. So this is a stem and leaf diagram. So in this instance, you were provided the diagram. So you need to convert, not necessarily convert, but you need to produce answers based on what you will be posed. For instance, A, how many scores of Hans 170 were registered? So within your stem and leaf, you need to produce how many scores of 170 were registered. Based on the frequency, this is more of a frequency, so you need to provide how many times. So we've got 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. So we've got 19, the total number of points scored. So within the period of 117, how many scores were recorded? So you'll have to check on your stem and leaf. Also, B, how many scores of 213 were registered? And C, what was the lowest score? D, what was the highest score? E, what were the common most scores? And F, were most scores above or below 200? So that is it with unit standard 09009. So moving on to the next unit standard, which is the learning unit 2, 7480. For session 1, you need to activity 1, you need to calculate and calculate the rational and irrational numbers with and without the use of a calculator. So you'll have to use add, minus, divide, times. So in this instance, you'll have to use a the BODMAS rule, where you see brackets. It's much, you need to use the BODMAS rule. So this is just your simple calculation that you can come up with. You'll have to come up with answers. You need to do addition, long division, as I've done on the previous exercise. Long division will actually help in terms of dividing. You can use long division. So this is the question, 15 questions that you need to answer for activity 1. And session 2, you need to calculate and evaluate, simplify the fraction. So for instance, in number 1, what you need to do, you need to apply to everyone. So when you simplify, you need to find a number that is divisible in both terms. So 3 is divisible to 9 and also to 12. So we put it in the simplest form in order for us to actually make it much more easier to solve. So 9 divided by 3 will give you 3, and 9 divided by 12, it has to give you 4. Yes, so we managed to simplify further within our 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 question that we were given. So what we'll do when we sorry what we'll do, we will use this format to say 9 divided by 3 over 12 divided by 3. This will equals to 3 divided by 4. So we simplified it further by finding a number that is divisible to both your numerator and your denominator. So you'll use that format to the rest of the questions that you're provided. Let's go about number 13. So we've got 35, 77 equals to 5 and 11. 5 over 11. So what we need to do, we need to cross multiplication. When we do cross multiplication, 33 times 11, it will give you 363 over 5 times 77. 5 times 77, it will give you 385. So we need to find the number that is divisible into the two numbers. That will make it much more easier, like the one we did with 9 and 2. So you'll use that. I won't continue any further. So you will find a number that is divisible in both numbers, so that you can make it simpler. Or what you can do, into 363, okay, we've got 3 4 3 6, and then this is 385. Is it 385? Okay, 385 divided by 3, 3, okay, T. So we can easily say, 121 times 3, it will give you that number, and 179 times 2, it will give you this number, 383. So we're simplifying it further up until we reach to the number that we wanted. So you can use many ways in order for you to simplify it further. So you'll use that approach for number 13. So that is for activity 2, and also activity number converting these fractions to decimals. You need to use long division. We have done that. You can use long division to convert from fraction to decimal. And also activity 3, we need to apply BODMAS. So BODMAS, we need to apply BODMAS within this this question. So for instance, number A, according to BODMAS, we need to solve that what is within our brackets. Fine. So between division and addition, so we need to solve out before what is between division and addition, which comes first. It's always division. So in this instance, what we need to do, we've got 5 over 8 plus 2 over 3. So we need to find a denominator that is divisible to these two. So let's check. 8 is 16, it's 24, and it's 40. Let's check 3. So it's 24. So 24 in these two. Let's just verify. 8 Yeah, 24. That's 24. So let's do this. So we've got 24. What we need to do, we'll say how many times does 8 get into 24? No, 24 divided by 8, sorry. We need to say 24 divided by 8, it will give you 3. Then 3 times 5, 3 times 5, it's 15. 15, I've got a plus, and 24 divided by 3, it's 8. 8 times 2 is 16. So 16 plus 15, it has to give it 31. 15 plus 16 is 31. So it's going to be 31 over 24 times this. So we managed to solve out this. So you're going to use the same approach that I've used here in terms of you're going to use the same. This is 31, this is not 8, this is 31. So you're going to use the same approach with 1 over 3 plus 1 over 2. So the number that is divisible in this, the highest denominator within these are 6, is 6. So 6 6 divided by 3, it has to give you 2. It has to give you 2 plus 6 divided by 3 by 2, sorry, it's 3. So that will give you 5 over 6. So we've got 5 over 6. So you managed to work out, at least I've given an answer for A. So we've got a times. We can continue further by timesing. So we're not doing when we have a a a, a sum. When we have a sum where we've got a times like this, our approach will be timesing in this direction, compared when we have an equals to in between, where it will cross multiply. So in this instance, we will just multiply this and that and continue simplifying. So you will continue with this and continue further with the questions that are provided. And also that's it, I think. Okay, activity 4, what you need to do, same what we have covered in terms of adding your like terms and unlike terms. We need to simplify the following. In this instance, what you need to add here, that we've got our coefficient and your basis. So our coefficient is the number, and our base is a. So you can even see on this instance we don't have our coefficient, not even our coefficient, our exponent. So in this instance our bases are the same. We've got 5a and 3a. We can add these two. The same thing to 2b and 5b and c also. So you can add this. We can even simplify to say 5 plus 3, it will give you 5 plus 3 will give you 8. 2b plus 5b will give you 7, and c plus this c represent 1. So this c plus 2c, it will give you 3c. So you will use the same approach to rest of the questions. Where there is like terms, you add you can simplify further. Where there's no like terms, you cannot even simplify further. So that is it in terms of your basis, and that's it with the second unit standard. We'll continue further with learning unit 3, 4 and 5.